In the Lesson 5.2 example, How much do APGAR scores vary? We're going to find and interpret the standard deviation for a random variable. Earlier, we defined the random variable x to be an APGAR score for a randomly selected baby 1 minute after birth. This table shows the probability distribution for those APGAR scores again, and in the last example we calculated the mean APGAR score for a randomly chosen newborn to be mu equals 8.128, so somewhere between 8 and 9. Calculate and interpret the standard deviation of x. So calculating the standard deviation is a little bit of an involved process, but it's not too bad once you understand the formula. So the formula for standard deviation of random variable x is the square root of these sums, all these things added together, and what we're going to do is for each item in the table, that is 0, 1, 2, 3, 4, all the different APGAR scores, we're going to take that value, subtract the mean, square the difference between that score and the mean, and multiply by that value's probability, which is shown in the second row. And then we're going to do that for all of these values in the table and add them together. So let's go through this pretty slowly here. The first item in the table is 0, and we're going to subtract the mean of 8.128. We're going to square that difference and multiply by the probability of 0, which is 0.001. We can see that in the table right here. And then we're going to go to the next item in the table, which is 1. And we're going to find the difference between 1 and 8.128 and square it and multiply by the probability of 1, which is 0.006. We'll do it again for 2 and 3 and 4 and all the way up to 10. And we'll say for the last term, it's 10 minus 8.128. Square that difference and multiply by the probability for 10. And after doing all of those calculations, we'll get the square root of 2.066, or 1.437. So how do we interpret this number, the 1.437? We know that the mean was 8.128. And we can say that a randomly selected infant's APGAR score 1 minute after birth will typically differ from that mean of 8.128 by about 1.4 points. If you'd like to try a problem like this in your textbook, you can try exercise 9 in this section.